Okay, so we're doing the December 2021 Danish FP9 Folkeskolens afgangsprøve. It's the 1 hour paper. That's the paper that consists of usually around 50 short questions, no calculators, no reference books allowed. Section 1, number and algebra. It says Malta has got a part-time job. In February, Malta earned 1,104 kroner, and in March he earned 1,256. How much did he earn in total in February and March? So you've just got to add up the two numbers. 1104, 1256. Add those up. 0, carry the 1, 6, 3, and 2, 2, 3. 60. Number 2, Malta earns 75 kroner per hour. How much does Malta earn if he works 5 hours? So that's just 75 times 5. 5 5s are 25, 5 7s are 35, plus the 2, 375. Malta has to pay 8% in, it's a deduction on that he earns. How much does Malta pay in the deduction if he earns 1,500? So it's asking you 8% of 1,500 kroner. When you're working at 8% of a number, that's you're working at 8/100ths of it, because a percentage is just a fraction out of 100. And when you're doing a fraction of a number, you're multiplying. So it's 8 on the top divided by 100 on the bottom times 1,500. You can cancel out a couple of zeros on the top and bottom of that. So that's the same as 8 times 15, which I can do in my head, is 120 kroner. 8% of 1,500, 120 kroner. Moving on, the ever popular question with ingredients for a recipe. This is soup for 4 people. 1 onion, 25 grams of butter, 200 grams of potatoes, 1 litre of stock, 500 grams of broccoli, 2.5 deciliters of milk, and one piece of salt. Apparently that's the size of a piece of salt. Some salt. How many people can Ida cook for at the most if she's got 1,000 grams of broccoli? So the recipe is for 500 grams. So she's got twice as much as that, so she can cook for twice as many people. So not 4 people, but 8 people. Assuming she's got all of the other ingredients, of course. Let's just tidy up some of the mess I'm making here. Okay, how many grams of butter does Ida use to cook soup for 12 people? Okay, so the recipe is for 4 people. She wants to cook for 12 people, so she needs 3 times as much as the recipe. So 3 times 25 grams of butter is 75 grams of butter. And then how much milk does Ida need to cook soup for? Let's just delete all this. There we go. How much milk does Ida use for soup for 6 people? There it is. Okay, so the recipe is for 4 people. So she's got 6 people, so 6 over 4 is 1.5. So she's got enough for like 1.5, 1.5 recipes. Or not, she's got enough, but she needs enough for 1.5 of this recipe. So the recipe is for 2.5 deciliters of milk, and she needs 1.5 times that. And the 1.5, of course, was 6/4, because the recipe is for 4 and she needs it for 6. So we've got to do 2.5 times 6/4, or 6/4. 2.5 is the same as 5 over 2. 2 times 2 is 4, plus the extra 1 makes 5, so it's 5 over 2. So that's the same as 5 over 2 times 6 over 4. So 5 times 6 is 30. 2 times 4 is 8. So she needs 38ths of a deciliter of milk. Let's just go up here with this. 8 goes into 33 times to make 24 with 6 left over. So that's the same as 3 6/8, which is the same as 3 3/4 or 3.75 if you prefer. I think I'll do that as 3.75. Okay, moving on. Miller, Ida and Laura want to share a pizza. How big a share of the pizza does Laura get if the 3 girls get equally much each? Okay, so well, if they get the same each, they all get a third. So Laura will get a third, as will Ida and Miller. How big a share of the pizza does Laura get if Miller gets a quarter of the pizza, Ida gets a third of the pizza, and Laura gets the rest? Okay, so let's work out how much the other 2 get. So the other 2 get a quarter plus a third. To add up fractions, you need the denominator to be the same in both. So that's the same as 3/12 plus 4/12, which is 7/12. So the other 2 get 7/12, so she gets the remaining 5/12. Twelfths is a word that a lot of Danes have trouble with in English. Okay, exercise 4. The drawing shows the price in euro for a set of headphones and the price in Danish kroner for a keyboard. 1 euro corresponds to 7.47 kroner. How many Danish kroner does the headphone cost price correspond to? What is the price of the headphones in Danish kroner, in other words? Put an X on the amount that's nearest to the right number. Okay, so 1 euro is approximately 7.47 kroner. I'm just going to round that to 7.5 because we're just approximating here. So we're not looking for an exact answer. We're just looking for something that's in the ballpark of the right amount. And then 49 euros 95. Well, that's approximately 50 euros. So it's going to be 50 times as much. So the calculation I've got to do is 7.5 times 50. 7.5 times 50. Just doing this in my head, it might be easier to say. So 7.5 times 50. So what I do in my head is I double the 50 to 100, and then I half the 7.5 to 3.75. So it's all about the same as 3.75 times 100, which is quite easy to do as 375. So we're looking for a number that's in the ballpark of 375 kroner. And in fact, there it is, 375 kroner. Okay, and then, so let me just delete some of the mess I've made there. Boom, and delete. And then we've got to go the other way. How many euros, so the keyboard, which is priced in kroner, what is it in euros? So again, I'm going to start with the basic exchange rate that, I think I'll do it down here. So 1 euro is approximately 7.5 kroner. We've got to work out a kroner price to euro. So what we really need to do is work out what 1 kroner is worth in euro. So if we want, it's a bit messy that, if we want what 1 kroner is worth in euro, then we've got to divide everything by 7.5. So 1/7.5 of a euro is approximately 1 krona. But the price of the keyboard is actually that, which is close to 560 krona. So 560 krona is 560 times as much as 1 krona. So I'm going to multiply the euro amount by 560 as well. So 560 divided by 7.5 euros is approximately 560 krona. So I've just got to work out 560 divided by 7.5, which is going to be the same as 5,600 divided by 75, which is going to be the same as, I'm kind of going through my whole mental strategy here, which is going to be the same as twice as much, 11200 divided by 150, and then I can knock a couple of zeros off that, which is going to be the same as 1120 divided by 15. Now I'm spotting here that if I double that, I'll get another 0 on the bottom, so that's going to be the same as 2240 divided by 30, which is going to be the same as 224 divided by 3. So actually, without having to do too much tough arithmetic or get the calculator out, I know that the euro price is going to be something around the ballpark of 224 divided by 3. So let me just do that. 0, carry the 2, that goes 7 times, carry 1, and that goes 4 times with, to make 12 with 1, with 2 left over, so about 74 2/3 euros. So 75 euros is clearly our closest one there. So kind of lifting the lid a bit on my mental arithmetic strategy, and you might have other ways of trying to do 560 divided by 75, but there you go. But the essential calculation that got us to 75 euros was 560 divided by 75 from the figures given. Okay, just clear up my mess and move on. Okay, straightforward calculations here. I'm not going to do much explanation here. The important thing is to just notice whether you're doing plus, minus, divide or subtract. So I'm going to do these long ways. You might spot quicker ways of doing things, like something is close to a nice round number and you can find a shortcut that way, but I'm just going to go the long way. So 1 plus 9 is 10, 0 carry 1, 2 plus 9 is 11, plus the 1 makes 12, 2 carry 1, 1 that I carried, and 4, 4, 1, 2, 0. Next one, 905 minus 206. See, what you might do there in your head is do 905 minus 205, is obviously 700. So 905 minus 206, you're taking off one more, so it's going to be one less, 699. So without doing the whole carrying the figures rigmarole, you might just spot that there's a shortcut there. Okay, 7 times 508, which I'm going to flip round and do it as 508 times 7. So I've got the small number on the bottom. That'll make things easier. 8 sevens are 56, 6 carry 5, 7 zeros are 0 plus the 5 I carried, 7 fives are 35, 3, 5, 5, 6. Okay, and then finally, delete all that lot. 16048 divided by 8. 8 doesn't go into 1, carry the 1, 8 goes into 16 2 times, 8 goes into 0 no times. 8 doesn't go into 4, so no times. Carry the 4. 8 goes into 48 6 times, so it's 2006. If you've learnt your maths in Danish, you might have done this the long division way, which is like this: 16048. 8. 8 goes into 1 0 times. 0 times 8 is 0. 1 minus 0 is 1. Bring down the 6. 8 goes into 16 2 times. 2 times 8 is 16. Subtract, get 0. Bring down the 0. 8 goes into 0 no times. 0 times 8 makes nothing. Subtract nothing from nothing, get nothing. Bring down the 4. 8 goes into 4 no times. 0 times 8 is 0. 4 minus 0 is 4. Bring down the 8. 8 goes into 48 6 times. 6 times 8 is 48. 48 minus 48 is 0, nothing left over. It's essentially the same process. So where I got the 16 here from bringing that down, I got that there. Where I've got the 48 there, I got that there. You're just kind of remembering a bit more in your head, doing short division, whereas you're writing more stuff down, and it's a bit more kind of complicated on paper when you're doing long division. Okay, moving on. Put an X on the right result in each exercise. 2/5 plus a third. So 2/5 plus a third. To add fractions, you've got to have the same denominator. 5 and 3 both go into 15, so you can express both fractions as 15ths. So 2/5 times 3/3 makes it 6/15, and 1/3 times 5/5 makes it 5/15. So it's 6/15 plus 5/15, which makes 11/15, which is the bottom option. And then when you're multiplying fractions, it's just top times top, bottom times bottom. So 1 times 2 is 2, 5 times 3 is 15, 2/15. Write 60% as a fraction. 60% means 60/100ths. Any percentage is just a fraction out of 100. That simplifies, actually. You can divide top and bottom by, well, you can certainly divide them by 10. In fact, you can divide them by 20. So we divide by 20/20ths, which is the same as dividing by 1, so it's not making it any bigger or smaller. So in its simplest form, 60%, 60/100ths, is 3/5. How many percent is 20 out of 80? So 20 out of 80, as a fraction, it's 20/80ths. Fractions are out of 1, percentages are out of 100. So we want to multiply by 100 to get it to a percentage. So it's 20 times 100 divided by 80, which is the same as 2000 divided by 80, which is the same as, knock off a couple of zeros, 200 divided by 8, which I can do in my head, is 25. Plus, it's sort of obvious. You know 25% is a quarter. You can see 20 is a quarter of 80. Moving on, delete all the mess. Write a fraction that is bigger than a half and smaller than 2/3. Well, let's write both of those out of the same denominator. So a half is 3/6. A third is 4/6. So we want something that's between 3/6 and 4/6. Well, we don't want to write 3.56 because you don't want the mixture of decimals and fractions, but 3.56 you could write as 7/12ths, and then you've got a nice fraction that's got a proper whole number denominator and numerator and denominator, and it's bigger than a half and smaller than 2/3. So the obvious answer to that is 7/12. I can see I've missed a question out. 40% of an amount is 200. What is the whole amount? So you've got to be super careful here. That is a kind of question that trips people up every year because it's not asking you 40% of 200. Yep, so the answer isn't 80. A lot of people just scribble down 80 quickly because they do 40% of 200. The question is an amount after you've figured out 40% of it gives you the answer 200. What was the original whole amount? So you've got to say 40% is 200 kroner. So if you figure out what 1% is, 1% is, so you're just dividing everything by 40. So 200 divided by 40 is 5. So 1% of the amount would be 5 kroner. So multiply it by 100. 100% of the amount would be 500 kroner. So if 100% of the amount is 500 kroner, that's the amount. Just get that to stop messing about. 500 kroner. So if you review the question, 40% of an amount is 200. What is the amount? So if you just think about working out what is 40% of 500, then you can very quickly see that you do get to 200. But you've just got to be very careful with that question, to read the question carefully and not just do 40% of 200 because it's the first thing you kind of think of when you see the percentages. Okay, on to exercise 8, which is good old algebra. 7x equals 63. I just want to know what 1x is, so I need to divide by 7 to get to 1x. Got to do the same on the left and the right, so I've got to do both sides divided by 7, and 63 divided by 7 is 9, so x equals 9. That's a fairly straightforward one. Then we got, just tidying up here, then we've got 4x plus 3 equals 5x minus 7. We've got x's on both sides. So I'd like to take away as much x as possible from both sides so that I don't have that situation. So if I take away 4 x's from both sides, that's the most I can take away from both sides, then I'm just left with the 3 on the left, because the right side, what am I talking about? Because I've taken the 4x away, but I've got to do the same to the right side as well to maintain the balance. So 5x take away 4x just gives me 1x, which we just write as x, and then there's a minus 7 there. So 3 equals x minus 7. I'd like the x bit on its own, so I'd like the minus 7 to disappear. The minus 7 will disappear if I add 7, but to maintain the balance, I've got to add 7 on the left as well. So adding 7 to both sides, 10 is equal to x. There's my answer, x equals 10. Okay, and we move on. Clear a space, and we've got one with a fraction in. You know, over the years, it's surprising how similar all of these questions are. If you look over a few years' papers, very samey. Okay, x over 5 minus 4 equals 16. I'd quite like to get the bit with x on its own, so I'd like the minus 4 to disappear. The minus 4 will disappear if I add 4, but because an equation has to be balanced, I've got to add 4 the other side as well. X divided by 5 equals 20. I don't want to know what x divided by 5 is, I want to know what a whole x is. So to get from x divided by 5 to a whole x, I need to multiply by 5. But to maintain the balance, I have to multiply by 5 on the other side as well. So multiplying by 5 both sides, x equals 100. So x equals 100 is the answer. Moving on. See, this has been another very popular question over the years. So it says the sketch shows an octagon. So, you know, when you think of an octagon, you probably think of a regular octagon, but that is a shape with 8 straight edges, so it's an octagon. But you can also visualize it as rectangles and squares stuck together. So whether you want to think of it as that rectangle and some other bits, or maybe you might want to split it up that way and that way. That's what you have to do to solve these questions. So first of all, the perimeter. Omkreds is Danish for perimeter. And that's the distance all the way around. So the length all the way around of the figure is, so you've got 3a. This is interesting this time because it's all in A's. Quite often you have sort of A's in one direction and B's in the other direction, but all of this is in A's. So you've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 A's. The perimeter is 16A. Okay, and then the area of it. So as I said, we need to, whoops, that's not the right tool, is it? That one. We need to break it up a little bit. So let's break it up like that. Why not? Okay, so this rectangle here is 2a by 3a, so that's 6a squared. This rectangle here, okay, so you've got 2a there. This whole side is 2a, and this bit is a, so the little bit here is a. So that rectangle is 2a by a, which is 2a squared. And then this rectangle at the bottom, so it's a along the side and 3a along the bottom, so it's 3a squared. So altogether you've got 11a squared as the area of the figure. Moving on. Which expression has the same value as 4n irrespective what n is? Well, 4n just means n plus n plus n plus n, so it's that one. Which expression has the same value as m cubed irrespective of the value of m? So m cubed just means m times m times m, so it's that one. That's a fairly straightforward one. You ought to just know that straight off without too much thinking. Okay, you've got geometry and measurement, the good old question about converting units from one thing to another. So centimeters to meter. Anything with centi is 100. There's 100 centimeters in a meter. The centimeters are smaller, so you expect the meter number to be bigger. The centimeters are smaller, so you expect the meter number to be smaller because there's fewer meters to make the same amount of centimeters. Lots of centimeters, fewer meters. So we've got to do 705 divided by 100, which is 7.05. These are always just a question of shifting the decimal point the right number of places or adding the right number of zeros. Okay, 2.1 kilograms. Kilo relates to 1,000. There's 1,000 grams in a kilogram. Grams are smaller, so there's going to be more of them. So you've got to do 2.1 times 1,000. And hopefully just straight away in your head you're thinking, well, that's going to be about 2,000, isn't it? Because we're just doing 2 times 1,000 and a bit. So it's going to be 2,100. So I'd hope that's fairly intuitive. Okay, deciliters. Deci usually relates to 10. So there's 10 deciliters in a litre. So a quarter of a litre, which you can also think of as 0.25 of a litre. And then there's going to be 10 times as many deciliters because the deciliters are smaller and there's 10 deciliters in a litre. Deciliters are smaller, so there's more of them for the same volume. 2.5. And then there's the classic question they try to catch you out with in the end, relating to area and volume. You know there's 100 centimeters in a meter. but we're not talking about centimetres and metres, we're talking about centimetres squared. If I just try and find a square I can draw, will that do it? Let's try. Okay, so there's a square, and if it's 1 metre by 1 metre, then it's 1 metre squared. But if instead of metres we think about that in centimetres, then it's 100 centimetres by 100 centimetres. And 100 times 100 is 10,000. Because you can get 100 that way, but also 100 that way. So if you were fitting little centimetre squares onto a big metre square grid, you'd get 10,000 of them in. You'd get 100 across, and you'd get 100 up, 100 times 100, 10,000. So 1 metre squared is 10,000 centimetres squared. We're talking about 2.5 metres squared, so 2.5 times as much is going to be 25,000 centimetres squared. And not, as the classic mistake would be, not just 250. Okay, the sketch shows a triangle with a baseline G and a height H. It says sketch, so in English that would be diagrams not drawn to scale. Basically, whenever you see a diagram in an exam question, they don't want you just measuring it to get the answer. So the diagram's always a little bit wonky, so that you don't just measure the diagram. Give a suggestion for what the base and the height could be for the area of the triangle to be 24. So if you remember, the area of a triangle is a half times the base times the height. So we want 24 to be a half, or 0.5, times something. Well, we could pick any couple of numbers as long as the whole thing multiplies to give you 24. So we could, I mean, it would be nice to pick something that makes the 0.5 sort of disappear. So it could be 6, so that the 0.5 times 6 gives you 3. And then you're asking the question, okay, so what could the height be so that 3 times the height gives you 24? And then that would obviously be 8. So could be 3 times sorry, not 3 times 8. Could be 6 times 8. So the base could be 6 and the height could be 8. It's basically any two numbers that multiply to give you 48, because half the base times the height has got to give you 24. So the base times the height has got to give you 48. So any two numbers that multiply together to give 48. So you could have 1 with 48, or the other way around. You could have 2 with 24. You could have 3 with 16. You could have 4 with 12. 5 doesn't go, so you'd have to go into decimal, so that would be messy. 6 times 8, or any of those the other way around. So those are the whole number values that would do it. Could also go into decimal values, of course. Okay, the sketch shows two similar boxes. So they're mathematically similar, which means they're basically the same shape, but just different sizes. So all of the angles are the same. Proportionally, everything is the same. Corresponding sides in both boxes are in the same proportion to one another. The length ratio between the two boxes is 1 to what? So you can see that you've a 1 in the small box corresponds to a 2 in the big box. A 2 in the small box corresponds to a 4 in the big box. Everything in the big box is twice as much. So it's a ratio of 1 to 2 from the small box to the big box. Then it says the volume of the big box is how many times as big as the volume of the small box. Well, generally, if things are in the ratio of 1 to 2 for length, then once you think about areas, an area is a length multiplied by a length. So you're working in 2 dimensions. So the area ratio would be 1 squared to 2 squared, which is 1 to 4 for the area. And then volumes, a volume is a length multiplied by a length multiplied by another length. So the volume would be in the ratio 1 cubed to 2 cubed, which is 1 to 8 for volume, rumfang in Danish. So the volume is 8 times as much. And you can sort of see that a couple of other ways, of course. So let me just delete all that. So apart from what I'm saying here, which is generally true, and it's the topic of a whole other video I've made, you can also sort of visually see it. If the lengths are twice as big, then you can stack 2 up, but then you can also put 2 side by side lengthways and 2 side by side the other way. So you can just see how you can fit 8 of the small box in to the big box. Although, of course, the diagrams are always a bit wonky in exams. And then the other thing you could do, of course, is just literally work it out. So 1 times 2 times 3 gives you 6 for the small box, and 4 times 6 times 2 gives you 48 for the big box, and 6 times 8 gives you 48, or 48 divided by 6 gives you 8. The big one is 8 times as big. But there is always this, there is often this trick question where it's not a trick question, but it's a question that tricks people, that catches them out. Just because the lengths are in a certain ratio, 1 to 2 in this case, doesn't mean that the areas and volumes are in that ratio. In fact, you can be certain that they're not. Okay, moving on. Points P and Q have been put into a coordinate system. What is the coordinate of point P? Okay, that's fairly straightforward. So P is 6 across and 3 down. It's 6 minus 3. There it is. Which of the lines below is the equation of a line that goes through point Q? Okay, well, let's start drawing these lines. So the first line is y equals minus x plus 6. So generally speaking, a straight line takes the form y equals something x plus something, mx plus c, and the number in front of the x gives you the gradient, or the helning in Danish, and then the plus number on the end gives you the intercept, or skæringspunkt in Danish. The gradient is how steep it is, the intercept is where it cuts. So for example, y equals minus x plus 6, that's a line that cuts at 6 because of the plus 6 at the end, and then it's got minus x, which is like minus 1x, so that tells us that the gradient is minus 1. If it's got a gradient of minus 1, then for every 1 across it goes 1 down, 1 across, 1 down, so it's a line that goes down there, and then the same the other way. So that one certainly doesn't cut through Q. Let's just delete everything we've done here. Delete that. Let's have a look at the next one. Y equals 2x plus 5. So y equals 2x plus 5 is a line that cuts at 5, cuts the y-axis at 5, and then it's got a gradient of 2, which means that for every 1 across, it goes up by 2. So it's a line like that. It goes from 5, 1 across for every 2 up. And that's certainly not going through Q either, so we'll get rid of that one. There we are, nearly there. Next one, y equals minus x minus 2. So that's got a cut at minus 2 because of the minus 2 on the end. And then because it's minus x, which is like minus 1x, it's got to have a gradient of minus 1, which means for every 1 across, it's going to go 1 down. For every 1 across, it's going to go 1 down. So it's a line over there, nowhere near Q. Just deleting stuff now. Okay, let's have a look at the next one. Y equals 2x plus 1. Okay, so that's a line that cuts at 1, and then for every 1 across, it goes 2 up, because it's got a gradient of 2. 1 across, 2 up. 1 across, 2 up. So that does look like it's going through Q, doesn't it? So it looks like that's our answer. Just delete my mess here. Okay, so I'll put a cross in that one. Let's just have a look at the last one. Y equals x plus 4. So that would cut at 4 and then have a gradient of 1 because we've got 1x. So for every 1 across, it would go 1 up. Yeah, that certainly wouldn't go through Q. Okay, so it was the fourth option. Let's have a look at how we're doing for time now. Okay, we're on about 42 minutes. And we got 1, 2, 3, 4, 5. Yeah, looking fairly good for time at the moment. Just need to push on. Okay, sketch missing angles. Well, before I even look at the stuff, what I like to do is just go to the diagram and fill stuff in. So, what have we got here? We've got the two blue lines, which are parallel. So because the two blue lines are parallel, that means that angle W in there is the same as the angle in there, because you've got a Z shape that's called alternate angles in English. So let's just fill in some stuff. You've got 140 there, and it's on a straight line with an angle there that has to be 40, because they've got to add up to 180 because they're on a straight line. That makes the W 40 as well because of the Z shape, alternate angles. We have got a 90 degree, a 53, and they're all in a triangle there. So the triangle's got to add up to 180. So that means the U has got to be 37. 180, take away 90, take away 53. 37, okay. We have got, well, this angle in here has got to be 140 as well, because it's got to be the same as the 140 there. So it's alternate angles there. We've got the old Z shape. It's a bit stretched out, but it's two parallel lines and another line that crosses them. You've got 53 on a straight line with V. Straight lines have got to add up to 180, so that's going to be 127. And I think we've worked out everything that's got a letter labelled on it, haven't we? So angle U is 37, angle V is 127, angle W is 40. Okay, the drawing shows a figure seen from the front, side and on top, which figure matches the drawing. Okay, so let's just have a look through these. So from the front, now what do they even mean by the front? Do they mean that way, or do they mean that way? That's a little bit ambiguous, but let's have a look at the possibilities seen from the top. So they all in fact look like that from the top, don't they? So that's not particularly helpful. So this one here, the first one, from this side looks like 4 squares, and from this side looks like 4 squares with 1 sticking out. So that certainly doesn't match those two. So we'll rule out the first one. Just deleting stuff. This one here looks like 4 squares from that way, and then from this way, well, it looks like a little kind of L shape with 1 sticking out. So that's looking good for the question. That's looking like it's matching 2 of the diagrams we've been given. So I'm going for that one. Let's just look at the others. Well, it can't be this one because that's 3 blocks high, and these aren't 3 blocks high. And then this one here, well, from this side it looks like 4 squares, and then from this side it looks like 4 squares with an extra 1 sticking out. So that doesn't match those. So it is in fact that one. A lot of people just can't visualize those, and you know, however long they spend on it, they just can't convert that in their heads. And it's a sort of, you know, you're either good at that sort of thing and see it straight away, or you don't. Okay, question 5. Here are 5 rosette patterns. Put 1x in each of the lines of here for a correct answer. In which rosette pattern is there the least rotational symmetry? Let me just read that. In which in minst drainingswinkel, oh, the smallest rotational angle that can. Okay, I'm struggling with my Danish here. It's basically saying in which rosette pattern have you got to turn the thing at least 90 degrees to get the pattern to end up in the same place. So for example, this one here, you've only got to rotate it 45 degrees and you've got the same pattern in the same place. This one here, it's got rotational symmetry of order 6. It looks the same in 6 rotated places. 360 divided by 6 is 60 degrees, so you've only got to turn that one 60 degrees. This one, it's got rotational symmetry of order 3. It looks the same in 3 places if you rotate it. 360 divided by 3 is 120, so you've got to rotate that 120 for it to be the same. And it's this one here that's got rotational symmetry of order 4 that you need to turn it 90 degrees for it to be in the same place, because 360 divided by 4 is 90. So it's pattern B, where you have to turn it 90 degrees to get the thing to come up in the same place. And then it says in which rosette pattern are there exactly 6 axes of symmetry. So when they're talking about symmetry axes, they're talking about reflective symmetry. So this one here hasn't got any reflective symmetry. You can't draw a mirror line anywhere on that one, so that things look the same one side of the mirror line as the other side. Let's just clear up the mess again. Delete. Okay, so that one has not got any reflective symmetry. This one here, you can put a mirror line there. 1, 2, 3, but then also 4, 5, 6 in between. So D has exactly 6 mirror lines that you can put in, six axes of reflection. This one here hasn't got any reflective symmetry. This one here hasn't got any reflective symmetry. And then on C, you've got 1, 2, 3, 4, but also in between 5, 6, 7, 8 axes of symmetry. So there's only one that has exactly 6 axes of symmetry, and that was D. Okay, let's move on. Just checking the time here. Actually running a bit short of time, only 9 minutes left, and we've got 1, 2, 3, 4, 5, 6, 7, 8 questions left. So I've been going a little bit slow on this one. Okay, so you've got the diagram shows how many kilograms of different varieties of egg were produced in Denmark from 2010 to 2019. So from 2010 to 2019, the production of Boer egg, is that battery hen eggs, I think, fell by approximately how many million kilograms? So that's the blue ones. So in 2010 it was 32 million. In 2019 it was now I've got to be a little bit, actually got to be a bit careful here because the divisions are in twos, 2, 4, 6, 8. So in fact it's fallen from 34 to 14. So 34 minus 14, it's fallen by approximately 20 million. From 2010 to 2019, the production of ecological eggs increased by approximately how many million? Okay, so the ecological eggs in 2010, well, the bit that represents those has gone from about 43 to about 51. So it was about 8 million in 2010. But in 2019, it's gone from, let's just, got to read these across. So what's that, 45? Yeah. It's gone from, well, it hasn't gone from 45. It's in the top 45 to 67, I think that is. Why have I written 4? 67. So 15, 22. So it's gone from 8 to 22. So it's increased by approximately 14 million kilograms. And then from 2010 to 2019, the percentage increase in the total production of all types of eggs is how many percent? Okay, so it's gone from 51 to 7 to 67, hasn't it? So it's increased. It's increased by 16 out of an original 51. So we've got to work out 16% out of the original 51. So 16 increase out of an original 51. So that gives the increase as a fraction. Fractions are out of 1, percentages are out of 100. So we've got to do 16 on the top divided by 51 on the bottom times 100 on the top. So that's 1,600 divided by 51. We're just looking for an approximation. So if we just do that as 1,600 divided by 50 approximately, then that's the same as 160 divided by 5, which is 32. So about 32%. Okay, diagrams A, B, C and D show the age distribution amongst teachers at 4 different schools. Put an X in each line. Which diagram shows data from a school where over half of the teachers are between 40 and 60 years? Okay, well, let's have a look. So between 40 and 60, in this school, it's about 21% plus about 20%, so that's about 40%, so not that one. In this diagram, between 40 and 60 is about 30% plus about 25%, so that's about 55%. In this school, it's about 10% plus about 20%. And in this school, it's between 40 and 60, about 20% plus about 15%. So it's this one here, B, where over the half of the teachers are between 40 and 60. Next question, which diagram shows data from a school where there are more teachers under 30 than there are over 50? Well, let's have a look at each one in turn. So first school, under 30, you've got about 19% of the teachers, and then over 50, you've got 20% there and 20% there. Second school, under 30, that's only 10% of the teachers. Over 50, well, already more than 10%. Third school, under 30, you've got about 25% of the teachers. Over 50, you've got 20% of the teachers, plus about 25% of the teachers. And in the last school, you have got 30% of teachers under 30. And then over 50, you've got about 15% there and about 10% there. So it's the last one that has more under 30s than over 50s. Finally, the probability question. The drawing below shows 5 jars with red, white and blue balls. Ida has to pick a random one from one of the jars. Which jar gives Ida an equal chance of picking a red or a blue ball? Okay, so looking at them, it's got to be a jar that's got the same number of reds as blues in it, and that's A, because A has got 2 reds, 2 blues, so you've got the same chance of getting one or the other without having to do any calculation. Next one, which jar gives Ida the greatest chance of picking a red ball? Okay, so first jar, you got 2 out of 5, which is 0.4. Second jar, you've got 4 out of 10, which is 0.4 chance. Next jar, you've got 1 out of 7, which is less than 0.4. Fourth jar, you've got 4 reds out of, not 4 reds out of 8, 2 reds out of 4, which is a 50% chance or a half chance. And then the third one is 2 red balls out of 6, which is clearly less than half. So it's in D where she's got the greatest chance of picking a red. Final question, which jar gives Ida a 0.8 chance of picking either a red or a blue? Okay, so let's just work that out. So a red or a blue in the first one. So there's 4 reds or blues out of 5. And 4 out of 5 is 0.8. 4 divided by 5 is 0.8 or 80%. So it is in fact A. Let's just look at the others. 1, 2, 3, 4, 5, 6, 7 out of 10 for that one. So it's 0.7 in that one. 1, 2, 3 out of 7 for that one, which is about 0.42-ish. This one, you've got 3 out of 4, so that's 0.7 chance, or 0.75 chance of a red or a blue. And then on this one, you've got 1, 2, 3, 4, 5 out of 6, which is about 0.83 chance of a red or a blue. But the one that gives exactly 0.8 chance is the first one. And that was the exam.